Hi everyone, I'm Gina, and today we are going to be looking at the ionization of amino acids. So on the left, we have a pH of 1. A low pH is due to the high H+ or proton concentration, and that is characteristic of an acid. Now on the right, we have a pH of 14. A high pH typically has a low concentration of H+ or protons, and that is characteristic of a base. Let's take a look at our wonderful Henderson-Hasselbach formula. This formula tells us that there is a relationship between the pH and the pKa and whether the amino acid will be in the base or acid form. For more information about the relationship between the base and the acid and how it affects the pH and pKa, I have another video on the YouTube channel, so go ahead and search that up, or you can look on the Google Doc. But for the purposes of this video, I just wanted to show you that the pKa never changes. It is characteristic of that specific amino acid and it doesn't change. What does change is the pH or the environment. So I'm going to show you a quick way of how to tell if it's in the base or acid form, which will help you out with your calculations later on. So let's say I have an amino acid and its pKa is 4.8. The pKa kind of acts like a seesaw, the center of a seesaw. So whatever is to the left of it is going to be in that acid form. The definition of a Bronsted-Lowry acid is that it donates protons. So the acid form is going to have a proton or be protonated so that it is able to eventually donate that proton when need be. So if you're able to visualize the pH scale as a number line, any pH to the left of the pKa is going to be in the acid form and it is going to be protonated. So now if we go ahead and take a look at the pHs to the right of the pKa, it's going to be in the base form. The definition of a Bronsted-Lowry base is that it is a proton acceptor. Therefore, it's not going to have that proton, it's going to be deprotonated so that it is ready to accept that proton when need be. So now let's see what would happen to the structure if we were to put an amino acid with a pKa of 4.8 and an environment of pH of 2.4. Because it's to the left of that pKa, air quotes, balanced, it is going to be in the acid form. Because it is in the acid form, it wants to donate protons, so it is going to be protonated. Now, if we take a look at a pH of 10.5, because it's to the right and it is in the base form, it wants to accept that proton and be ready for it, so it is going to be deprotonated. So I wanted to show you a quick visual that has always helped me determine whether a structure is protonated or deprotonated when I'm doing my calculations. I know that my pKa never changes and my pH or my environment does. And so it looks a little something like this. But no matter what, if my pH is to the left on the number line compared to my pKa, it is protonated. And if my pH on the number line is to the right of my pKa, it is deprotonated. I hope this video cleared up some of the confusion, and I'll see you in the next one. Thanks for watching.